Hello everyone, I welcome you all to Startup Academy, India's exclusive coaching for ISS examination. In today's lecture, we'll be moving forward for continuous random variable distribution, and today's distribution will be gamma distribution. Now, gamma distribution, we'll be discussing about two kinds of gamma distribution, one with one parameter and the second with two parameters. So if we are talking about the first case, which is the gamma distribution of first kind or one parameter. If there is a random variable x, which is a continuous random variable, and it follows gamma distribution can be represented by the Greek letter gamma and with the parameter as lambda. Or gamma distribution can be represented by capital G with the parameter lambda. So this is known as one parameter gamma distribution, and its PDF is given by fx lambda is equals to 1 upon gamma of lambda. This is known as gamma of lambda e raised to the power minus x and x raised to the power lambda minus 1, where both x and lambda are greater than 0. This forms our PDF of gamma distribution, and this is important. From here only we'll be doing various things. Now there are some properties of gamma distribution. Properties of one parameter gamma distribution. Okay, let us first discuss, then property we'll be doing simultaneously. Now if we talk about the second gamma distribution, which is gamma distribution having two parameters. So if there is random variable x which follows gamma with two parameters, beta and lambda, or we can say capital G, beta and lambda, then the PDF of that would be fx beta lambda is given by beta raised to the power lambda upon gamma lambda x e raised to the power minus beta x and x raised to the power lambda minus 1, where all beta gamma where all beta lambda and x are greater than 0. So this is our gamma distribution with two parameters beta and lambda having this PDF. This is also important. Now we'll be simultaneously uh, discussing about the properties of these two distributions so that you know the difference between both of them. So if we talk about x follows gamma lambda, which is one parameter, and x follows gamma beta comma lambda, which is two parameters. Now the first property is mean. If we talk about mean of both of them, then it will be lambda, and it will be lambda upon beta. If we talk about variance, then variance of this will be lambda only, and variance of this will be lambda upon beta square. If we talk about MGF, that would be 1 minus t raised to the power minus lambda, and here the MGF will be 1 minus t upon beta raised to the power minus lambda. And if we talk about the characteristic function, then it would be 1 minus it raised to the power minus lambda, and here it will be 1 minus it upon beta raised to the power minus lambda. There is one more property of these, that summation of gamma variate follows gamma variate only. So if we talk about summation of xi's, I goes from 1 to n, xi follows gamma with summation of I goes 1 to n lambda I. And here summation of I goes from 1 to n xi follows gamma with beta and summation I goes from 1 to n lambda I. This will be our final properties where we are talking about summations. So one more property is there of mode. It is lambda minus 1 for one parameter distribution and lambda minus 1 upon beta for two parameters distribution. That's it. That's all the properties that we have to do. Other properties that would be required, we'll be discussing in between the questions. Let us move to questions. So our first question of today, they has provided us with that x follows gamma, and they have given the values of lambda and beta, where lambda is 2 and beta is 1 by 2. And they have asked us probability of x is greater than 4. Now we know that fx is nothing but beta raised to the power lambda upon gamma lambda e raised to the power minus beta x and x raised to the power lambda minus 1, where lambda, x and beta all are greater than 0. Now if we put the values here, this 2 is the value for lambda and this half is the value for beta. So putting the values of 2 and half here, it will be 1 by 2 raised to the power 2 upon lambda 2 e raised to the power minus 1 by 2x, x raised to the power lambda is 2, 2 minus 1. So this will be our 1 upon 4. Now lambda 2, gamma 2. If we talk about gamma 2, then it will be 2 minus 1 factorial, which will be equal to 1 factorial, and 1 factorial is nothing but 1. So it will be 1 e raised to the power minus 1 by 2x, and x raised to the power 2 minus 1 will be x only. So I'm writing it here. So this will be our PDF. Now if we're talking about that, we have to find the probability that x is greater than 4, then it will be integration from 4 to infinity fx dx. Fx we have calculated x upon 4 e raised to the power minus 1 by 2 x dx, and this will be 1 upon 4 integration 4 to infinity x e raised to the power minus x by 2 dx. Now this will be the integration of two components. One is this, let us consider one this and second this. When we integrate this, the formula is the integration of uh, d by first into integration of second minus d by dx of first into integration of second and whole integration. This is the formula. We all know this formula. This is the formula for integration, double integration. And on solving with this formula, we'll be getting our answer as 1 upon 4 into 8 e raised to the power minus 2 plus 2 into 0 plus e raised to the power 2 e raised to the power minus 2, and this will be 1 upon 4 into 12 e raised to the power minus 2, which is 3 e raised to the power minus 2, which forms our option number A. So in this question, you just have to know about the integration, how to solve it with the integration, and rest all you will be able to solve it. Now moving forward with another question of similar kind. Here they have given us the PDF where beta is represented by alpha and lambda is represented by p, and they have given us e raised to the power x is mean is equals to 20 and variance is equals to x. Now this is two parameter distribution. X follows gamma with beta. In place of beta they have provided us with alpha, and in place of lambda they have provided us with p. Now we know that mean of x is nothing but, what, for two parameter distribution it is nothing but lambda upon beta, but lambda is p and upon beta is alpha, and variance of x is lambda upon beta square, which is p upon alpha square. Now they have provided us that mean is nothing but equal to 20 and variance is nothing but equal to 10, and they have asked us the values of alpha and p. So if we take from one, let us consider this equation number 1 and 2. So if we take p is equals to 20 alpha from equation 1 and put the value of p in equation 2, 20 alpha upon alpha square is equals to 10, then alpha and alpha will get cancelled and 1 0 will get cancelled from here. So we get the value of alpha is equals to 2 from this, and if we put this alpha is equals to 2 here, then we'll be getting 20 into 2, which is equals to 40. So our value of alpha is equals to 2 and value of p is equals to 40. The one which matches our answer is option number B, where alpha is the first value, which is 2, and p is the second value, which is 40. Moving forward to another question. Now, here we are using one of the properties of exponential distribution. Let us see what is the property of exponential distribution. Suppose x follows exponential lambda. Suppose x is following this. Now summation of xi, I goes from 1 to n, will follow gamma distribution with lambda and n. This is the property of our exponential distribution, where summation of exponential distribution, summation of IID random variables of xi's will follow of exponential distribution will follow gamma distribution. So now we'll move back to the question. Here they have given us that x1 and x2, they have given us 2. So summation of I goes from 1 to 2, xi follows gamma with the parameters. Now exponential is 3, so lambda will be equal to beta will be equal to 3, and they have given us n is 2, so lambda is equals to 2. So this forms our gamma distribution, and they have asked us to find the probability of x1 plus x2, which is this only. So let us consider this as u. So summation of xi we have considered as u. Now f of u, which is PDF of u, will be equal to beta raised to the power lambda, which is 3 raised to the power 2 upon gamma lambda, which is gamma 2, and e raised to the power minus beta x, which is minus 3x, and x raised to the power lambda minus 1, 2 minus 1 will be equal to 1. This is the PDF, and they have asked us to calculate the probability of x1. In place of x1 and x2, I can write u is greater than 1. So it will be integration from 1 to infinity fx, which is 9, gamma lambda is 1, e raised to the power minus 3x into x dx. This is all we have to find. Now this integration will be equal to 9 come outside as it is a constant, 1 to infinity, x into e raised to the power minus 3x dx. Now this forms our function 1 and this forms our function 2. And again, by using the two function integration formula, which is integration of 1 into integration of second minus d by dx of 1 into integration of second with the whole integration. This again forms our two function integration. Now solving it with this, we'll be getting our answer something like 3 e raised to the power minus 3 plus e raised to the power minus 3, which will form as 4 e raised to the power minus 3. You can solve it on your own. I'm just writing the final answer, which forms our option number C. So that is how you solve the double integration formula. Now moving forward to another question. This is our this has our one more property. Now if we're talking about one more property, then if we talk about x is a variable which follows normal distribution with mean mu and variance sigma square, then x square will follow chi-square distribution with degree of freedom 1, and 1 upon 2 x square will follow our gamma distribution with degree of with lambda equals to 1 by 2. So this is the main thing that we need to know for this question. And if we are talking about x follows normal 0 and 1, then also this property follows. X square is chi square 1 and 1 upon 2 x square follows gamma 1 by 2. But here instead of x square we have to take y square, where y is nothing but equal to x minus mu upon sigma whole square, upon sigma only, whole square we have put. So here, since we know that 1 upon 2 x minus mu upon sigma whole square follows gamma with parameter 1 by 2, then the mean, this is equals to lambda, then the mean is lambda, which is 1 by 2, and our variance is also lambda, which is 1 by 2. So they have asked in the question the mean and the variance. So mean and variance both are 1 by 2, 1 by 2, which is our option number A. Now the last question, this is a statement question. We just have to know about the statements. We just have to compare. They have given us two variables x1 and x2. Both are independent variables and follows gamma. So x1 follows gamma, beta and alpha 1, and x2 follows gamma with beta and alpha 2. Now mean of this x1 will be alpha 1 upon beta, and mean of this one will be alpha 2 upon beta. So they have asked us what consider the following statement: variance of x1 is equals to variance of x2. If we talk about variance of this x1, then it will be alpha 1 upon beta square, and variance of x2 will be alpha 2 upon beta square. And if alpha 1 is equals to alpha 2, then variance will be equal. Yes, if we take alpha 1 is equals to alpha 2 is equals to alpha, then variance of x1 will be equal to alpha upon beta square, and variance of x2 will be alpha upon beta square, and both of them are equal. So our equation number 1 follows and is true. Now the second one, x1 plus x2 has gamma distribution beta alpha 1 plus alpha 2. I've told you that when we talk about summation I goes from 1 to n, xi, which follows gamma distribution with beta, and summation I goes from 1 to n lambda I. Now here, instead of lambda, they have given us alphas. So we can take it as alpha I. Now, if we are talking about two variables, so x1 plus x2, instead of summation xi, I can write x1 plus x2, which follows gamma distribution with beta alpha 1 plus alpha 2, summation of alpha i's. So this matches our option number 2, and hence our statement 2 is also true. So these questions and the properties covered all of the gamma distribution. I hope you understood whatever we have done today in the class, and if not, then you can ask in the comment section or on our WhatsApp channel. Only relevant doubts will be answered. All the best. Thank you.
Startup Academy.